Hello, in this video I will be talking about the cover-up method. Let's say we have this fraction of polynomials, 2x minus 3 over x minus 1, factor of x plus 2, factor of x. First of all, this type of fractions is called a proper fraction because the degree of the numerator, which is 1, is strictly less than the degree of the denominator, which is 3 if we expand the denominator. Now, if we decompose this fraction of polynomials into what we call partial fractions, the decomposition is done as a over x minus 1. This is the first partial fraction, plus b over x plus 2 plus c over x. So we take each factor of the denominator and we decompose it into partial fractions. Always in a partial fraction, the degree of the numerator is minus 1 the degree of the denominator. So if the degree of the denominator here is 1, so the degree of the numerator would be 0. So it's going to be a constant. Now, it's not the goal of this video to show you how do we decompose a fraction of polynomials into partial fraction. The goal is to explain the cover-up method, which is a method that we can use to find the unknowns a, b, and c without taking a common denominator and identifying with 2x minus 3. So this method, the cover-up method, we can use it here because the denominator in each partial fraction is a linear factor, so it's of degree 1. Let's start with a. We look what is the denominator in the partial fraction that contains a. It's x minus 1. So what we do is that we cover this factor in the left-hand side here, or we delete it, whatever you want, but since it's called the cover-up method, so we cover it. And in the remainder, not the remainder, and what remains from this fraction, we replace x by 1, because 1 is the number that makes x minus 1 0. So here, a, we obtain it by covering x minus 1 and replacing x by 1 in what remains from the fraction of the polynomials from the left-hand side. So replacing x by 1, we get 2 times 1 minus 3 over 1 plus 2 multiplied by 1, which is minus 1/3. So a is minus 1/3. Now the same is done for b. So the denominator of the partial fraction of b is x plus 2. So we will cover x plus 2 and replace x in what remains from this fraction by minus 2. So b is going to be, as I said, we cover x plus 2 and we replace x by minus 2. So it's going to be 2 multiplied by minus 2 minus 3 over minus 2 minus 1 factor of minus 2. So it's going to be minus 7 over 6. Also, c, we cover or we delete x, and in what remains from the left-hand side, we replace x by 0, because here it's c over x. So what makes x 0 is the number 0. So c is going to be I deleted or I covered x, and I'm replacing x by 0. So c, it's going to be 3 over 2. Where do we use this cover up method? Let's say we want to integrate. Now we want to integrate 2x minus 3 over x minus 1, x plus 2, x plus 3. So we decompose it into a over x minus 1 plus b over x plus 2 plus c over x. And we have found that a is minus 1 over 3, c is minus 7 over 6, and b is minus 7 over 6, I'm sorry, and c is 3 over 2. So we transform this fraction of polynomials into partial fractions that we can easily integrate. And then I split this integral into 3 integrals: minus 1/3 integral of 1 over x minus 1, minus 7 over 6 integral of 1 over x plus 2, plus 3 over 2 integral of 1 over x. All of these integrals are of the form u prime over u, because if u is x minus 1, its derivative is 1. So it's the integral of u prime over u, and it's going to be ln absolute value of u. Always when the partial fraction has a polynomial of degree 1 in its denominator, its integral is going to be ln. So at the end, we will get minus 1/3 ln absolute value of x minus 1, minus 7 over 6 ln absolute value of x plus 2, plus 3 over 2 ln absolute value of x, plus a constant c. Don't forget to subscribe to our channel. Thank you for watching.